Today, everybody, we're going to start the conic section dealing with hyperbolas. Hyperbolas is different from an ellipse because when you're dealing with distances, the differences are going to be equal to each other, not the sums. So if I have a 12 from here to here and a 2 from here to here, that difference would be 10. So if I said this distance right here was a 1, what would this distance right here have to be?
11.
Okay, that would have to be an 11. All right, so that's how hyperbolas work, because 11 minus 1 would still get us to a 10. How is a hyperbola created? A hyperbola is created, let me scan to the picture here. You guys see these two cones right here? The tip of the cone is right there. If you take a plane, all right, and you run it perfectly vertical or perpendicular to the bases of the cone, it creates this shape. You can kind of hardly see it here. You can see this, that curve right there, and then this curve right down here. That's how a hyperbola is created. It's when you take a plane and you cut it through two cones, and the tips of the cones are touching right there. All right, so here's a picture of hyperbola and all the parts that are labeled. In an ellipse, what did we call the axis that ran through the foci, through focus 1 and focus 2? We called that the major axis, okay? In a hyperbola, we call it the transverse axis, okay? And then what was the conjugate axis called in an ellipse? Called the minor axis, okay? Now the difference here is the major axis in an ellipse was always the longest. I'm letting you guys know the transverse axis is not always the longest, all right? But it is the one that always passes through the foci, focus 1 and focus 2. What we're going to do, all right, is we're going to do problem number 1 in your journal, all right? We're going to take this equation right here, and we're going to work from beginning to end, and then we're going to build the ellipse, not the ellipse, build the hyperbola in your journal, okay? So right now, everybody, please write this equation out, and we're going to go from there. The first thing you have to do when you're given this information is you need to organize all of your x variables and y variables together. So we're going to start out with the x squareds. So x squared minus 4x, I'm going to put a empty little square right here. That's going to help us complete the square. I'm going to change colors here. I'm going to put minus 4y squared plus 24y. I'm going to put an empty little square right there. Equals positive 36. Now what I did is just took this negative 36 and just moved it across the equal sign. So now you have a positive 36. And whatever I add to one side of the equation, I'm going to have to add to the other side. So I'm going to have a couple of spaces here that we're going to fill in when we complete the square. So go ahead and get that down. You're organizing all of your x's right here and all of your y's right there. Now, before we go ahead and keep working, I'm going to go back to the actual final formula and what it looks like. And there's something interesting. I'm going to go right up here. I'm going to zoom in. Watch it. That's pretty good. Do you guys see how everything looks pretty similar to the equation for an ellipse? The only difference, everybody, is really that it has a what? It has a minus instead of a plus, okay? And what happened when we look back at our picture right here, notice what's happening between the distances. They're being subtracted. With an ellipse, they were being added, okay? So now that we know that, when we build this, understand whenever you guys see a minus sign right here, that lets you know, oh, you're going to be building hyperbola. If this was a plus and not a minus, if this was a plus, we would be building an equation for an ellipse. Now, of these right here, of the blue and the green, which is the easiest to complete the square? The blue or the green? The blue, because this one already has a 1 in front of it. What is the c value right here always going to equal? B value divided by 2 squared. Now, you have no idea what I'm talking about as far as the C value. I'm dealing with the basic concept of a quadratic equation where you have a, b, and c. When you're completing the square, your a value needs to be a 1. The b value is just whatever it is. When you're completing the square, the c value is always whatever the b value is divided by 2 squared. So what's half of a negative 4? Negative 2. Negative 2 squared is 4. So if I put a 4 here, I can simply put a 4 there. Okay, and that part's done. Now, what does this factor? What does this factor to? What is x squared minus 4x plus 4 factor to? X minus 2 and x minus 2, which becomes x minus 2 being where? Squared. There you go. All right, the next one's a little bit more difficult. I want you guys right here to put a minus, and I want you to put a 4, because we actually have to take a negative 4 and factor it out of the entire equation. So if I factor a negative 4 out of all of my y variables, I'm going to be left with a y squared minus a 6y plus whatever goes right here. Now, how does this work? How do you check your work? Take the negative 4, multiply it to the y squared, and that should give you this value right here. Then take the negative 4 and multiply it to the negative 6y, and that gets you back to your positive 24y. So whenever you factor out a negative, what's going to happen? This is going to go from a positive to a negative. You've got to be careful with that. Now, at this point, it's easy once again. I just got to take what? The b value divided by 2 and square. There's your b value. What's half of negative 6, right? Negative 3, sir. Okay, what's negative 3 times negative 3? Sorry, that is 9. Good. Okay, so put a 9. Now, you have to be careful right now, everybody, because even though you put a 9 here, I am not going to put a 9 right there, because technically this 9 is being multiplied by a negative 4. So Liz, what am I going to put over here in this space? Yeah, that's right, negative 36. All right? So even though I put a 9 here, I'm not putting a 9 there because this 9 is actually, once again, being multiplied by the negative 4. All right, let's put a negative 36 right here. All right? Because basically, what did I end up doing to both sides to balance it out? I put a minus 36 and a minus 36. Which, yes, this right here, if you factor everything out, you take a negative 4 out of that, what is negative 36 divided by a negative 4? A positive 9. Now, the next thing we have to do is we need to factor this right here. So what is y squared minus 6y plus 9? What does that factor to? Y minus 3 and a y minus 3. Now, this is all equal to 4. You're right, Myra. That right there, we have 36 minus 36, and we have a 4 left, so that's all equal to a 4. Now, we're almost done. We have x minus 2 squared minus 4 times y minus 3 squared equals a 4. We don't want this, we don't want our x squareds minus our y squareds, we don't want them to equal a 4. What do we want them to equal? We want to equal a 1. So the very last step that you would have to do, divide everything by a 4. And here is your final equation. Now we're going to take this equation and we're going to graph this hyperbola. But the final equation that you're going to have on your paper is this. Now, even though these 4's cancel out to a 1, make sure you leave a 1 in the denominator, okay? This is your final answer. I want you guys to understand something. That 4 represents your a squared. That 1 represents your b squared. So go ahead and take that and transfer it over to your paper. Then we're going to keep working in your journal. All right, now that we have this information, I want us to label something. We're going to put H comma k, which represents the center of the hyperbola. All right, that's going to be at a 2, 3. This right here is your h value. This right here is your k value. All right. My a value is 2. My b value is 1. All right. If a squared is 4, the square root of it is 2. The square root of 1 is 1. Now, something you might want to write in your journal is you might want to write this down. The transverse axis, okay, will always equal 2 times a. And the conjugate axis will always equal 2b. But the transverse axis will not always be bigger than the conjugate. Whereas in an ellipse, the major axis is always bigger than the minor axis. Okay? So now we have this right here. Now we're going to teach you how to take this information right here and build your hyperbola. All right, the first thing you do when you're building a hyperbola is you plot the center. So we're going to plot 2, 3. Plot 2, 3. Now, from the center, everybody, I want you to go over 2 units and put a point. Then go over 2 units to the left and put a point. Now, why did I go 2 on either side? Understand, this is going to be your distance called A. So from here, my A value is 2, so I'm going over 2 to the right and 2 to the left. From where? From the center. Okay?
On the other one, you just go 1.
You go up 1, put a point.
Go down 1.
Go down 1, put a point. Now, this is going to be the most important part. You need to build a rectangle that goes through the dimensions built by your points. There we go. I want you guys to build a nice, neat rectangle just like that. All right, after you have your rectangle done, next thing we're going to draw are the asymptotes that are going to pass through the center. So how do you draw on your asymptotes? From the center, go through a corner of the rectangle. So it looks like you go what? Up 1 and over 2. So you should keep going. Up 1, over 2, up 1, over 2, up 1, over 2. All right? And you keep building it. Down 1, over 2, down 1, over 2, down 1, over 2. So there is one of my asymptotes. I'm going to label it real quick. All right, the next asymptote, once again, you start at the center, and you go to the other corners of the rectangle. So this one is going down 1 and over 2 to the left. That's a negative half slope. Okay. There we go. So there are your asymptotes right there. All right, now that I have my asymptotes, we need to find the foci for our hyperbola. By the way, the formula has now changed. In an ellipse, it was c squared equals a squared minus b squared. Now it's a squared plus b squared. Our a squared was 2 squared, which gave us a 4. Our b squared is 1 squared, which gives us a 1. So our c squared is 5, which means c is equal to the square root of 5, which that's approximately equal to about a 2.2. All right, that's what that's approximately equal to. So our foci, everybody, is going to be h, which was 2, plus or minus what? Plus or minus the radical 5. Put 2 minus radical 5, comma 3, and 2 plus radical 5, comma 3. But I'm going to use the approximate values and plot those. So these are the approximate values for the coordinates for the foci. One of them is going to be right over here at about a 4.2. The other one, comma 3, the other one's going to be at a negative 0.2. Now, how do you draw in your final answer? I want you guys to understand. This blue point, that's referred to as a vertex. This blue point, that's another vertex. Your hyperbola is actually going to go through both of these vertices. So all I want you to do for your final answers from your vertices, I want you to draw a curve getting close to the asymptote but not crossing it. You'll have another curve going through your vertex, getting close to the asymptote but not crossing it. And this is your picture of your hyperbola.